All right, hi everyone. Can you guys see now? Okay, I think we're back on. Sorry for the technical difficulties there. All right, so if everyone can see what I've got here, let me kind of recap what I was just talking about, and we'll keep moving from there. So the app that I'm going to kind of walk through today takes advantage of a bunch of sort of the modern cloud features that we know application developers are trying to use to build their applications. And so there's a few things you'll see in this diagram. This is a video thumbnailer. We're going to build some pieces of this. We're going to combine together containers. So in this video thumbnailer, that was FFmpeg, but this could be any piece of compute that we want to bring and run in the cloud. We're going to combine lambdas, and lambdas really give us the ability to sort of do event-based computation. When something happens, run a piece of code and react to things. And then we're going to use sort of managed data services. And so in this case, that's S3. We're going to also maybe throw in some Dynamo tables and things like that and see how we can bring managed data services from the cloud platforms into our application. And really the thing that's sort of unique about Pulumi is the ability to sort of work with all three of these pieces and combine them all into my application and compose them together really quickly into my app. And so let's kind of take a look at what it looks like to do that from scratch. So I'm going to come in here to my terminal. I have the Pulumi CLI installed. Once you run that installer command I showed a second ago, you'll have the Pulumi CLI. The first time you get Pulumi, you'll want to log in to the service so that you can run all the other commands. And then the next thing you can do is just say Pulumi new. And in my case, I'm going to say, well, actually, let me make a new directory here. I'll just create a demo directory. And then I'm going to say Pulumi new AWS TypeScript. So Pulumi supports JavaScript, TypeScript, Python. I happen to have a personal connection to TypeScript, so I'm going to work with TypeScript today and show off a couple of things we can do there. But all these demos should work just fine in JavaScript or TypeScript or Python. So let me start with the demo app. I'm going to run this in US West 2, just so it's a little bit closer to me here in Seattle. And then it's going to go and install the dependencies. So one thing to note about this installing dependencies, because we're using TypeScript and JavaScript here, these dependencies are node packages. And so all of the libraries that we're going to use to connect to the cloud providers and build cloud software are delivered as node libraries. And so you'll see things like @pulumi/AWS is a library that we just ship in NPM. And these libraries we can install just like we would any other NPM component, and it means that you can also build your own Pulumi libraries and ship those in NPM and have other folks use them. We're going to have all these libraries be open source as well, and so folks can come and contribute to these libraries that we've built and build their own and share them with others on NPM. Okay, so let me just open up a editor here and look at this code. So I'll go ahead and just sort of delete the default code here, and we'll start really from scratch here. So the one thing I want to do before I get started, here you see I have two of these packages, Pulumi and Pulumi AWS. Pulumi gives me all the sort of basic things I need to use Pulumi from within my programs, and Pulumi AWS lets me connect to and create resources inside AWS. And Pulumi AWS has sort of all the things you might expect, so S3 bucket and bucket notifications, EC2 instances, DynamoDB, all a variety of different kinds of resources. And overall, I think there's something like 500 different resources that AWS exposes and are available here to program against directly using the Pulumi AWS package. Of course, there's similar libraries available for Azure, GCP for targeting Kubernetes, that sort of thing. But in this example today, instead of just using those AWS resources directly, what I want to use is some higher level frameworks that combine together those resources and make them much easier to use. And so this is where you'll really see the benefits from Pulumi, is when you use higher level frameworks that people have built that package together commonly used components. So let me come over here and I'm going to say npm install @pulumi cloud and @pulumi cloud-aws. So I'll go and show these libraries off a little bit in more detail soon, but Pulumi Cloud and Cloud-AWS are just some high-level cloud programming frameworks that build on top of all those primitives from AWS. that we have found really useful working with customers we worked with during the private beta, and that we've put into these packages for everyone to use. One key thing about these are just some useful patterns. You don't have to use these, or you can build your own patterns like these. You can come and contribute to the ones that we've built so far. We really think of these as just sort of a nice starting point for getting started and quickly building up some really productive cloud applications. Okay, so let me come into some code and start using those. So I'm going to say, I'm going to import that. And now we can see what is available here. So let me create a simple bucket. So I'm going to say new cloud.bucket. And here we notice that in this cloud package we have a bucket class. This bucket class really is just a wrapper over that AWS, creating an AWS bucket. And I'm going to call it bucket. Now the interesting thing is that this bucket class exposes some additional capabilities. So one of the things it exposes is the ability to hook up events. And so I can use onPut and onDelete. And these do all of the heavy lifting to combine together the various different resources that AWS provides to hook up events to an S3 bucket. And so in a second we'll go ahead and use that onPut, but before I do that, let me just export the name of this bucket so that we can see it from our code. And so I'm going to say bucket name equals, and then I'll say bucket, and this is a bit funny. This is my bucket. That thing has a property called bucket, which is the S3 bucket inside it, and that S3 bucket itself has a property called bucket, which is the name of the bucket itself. So you can see that here in the definition. So I'm going to take that, and since that's just the name, I want to go and create S3:/ and then name, and that will give me the qualified URL for accessing the bucket. Okay, so let me just take that program. One more thing I want to do, since I'm using TypeScript, I'm going to run the watch task here just so I'm constantly building this and don't have to think about building my code. Okay, so now I'm going to come over into my terminal and I'm just going to run this program. So to run the program and stand it up and to update a stack, I'm going to say Pulumi update. So Pulumi update, since I haven't yet deployed my app, this is going to deploy it from scratch. So it's going to deploy all the resources that my program indicates it wants, and it's going to deploy those into AWS. And in particular, since I said I wanted to run this in US West 2, it's going to deploy this into the Oregon region of AWS. And so you see here, I get a description when I run Pulumi update of what it's going to deploy. And so we see it's going to deploy that AWS S3 bucket. You can see that the AWS S3 bucket is being deployed because it's part of this cloud bucket component, which I used to create it. And so if I want to get more details on what's being created, I can sort of click details here and see all the properties of the bucket I'm going to create. But let me go ahead and say yes, and go ahead and create that bucket resource now. Okay, so this is going to take a second to provision the bucket in AWS. And then when it's done, we'll go ahead and look at that bucket. Okay, so it finished in a few seconds there, and so now let's go and look at a few things related to this. So first off, I exported that bucket name, and so here we can see I have the name of a bucket. And so if I use my AWS command line, I can say AWS S3 ls, grab this. And I can see, well, there's nothing currently in the bucket. But if I copy some file in there, so maybe I'll copy my pulumi.yaml into here. I've uploaded that, and so now if I look at what's in here, I can see that my pulumi.yaml file is up in S3. So I provisioned an S3 bucket, and I can interact with that from the command line here. Okay, so the other thing I can do is I can get this link and go and see kind of all the information that Pulumi understands about my program. And so for this stack, we can see that I've only done one update, the one that I just did. We can see some of the details about it, like the region I've configured, the bucket name that was that output, and I can also see the list of all the resources. And I can go and click the AWS link to jump over into AWS and see all the contents of my bucket. So here's that Pulumi YAML file again. So okay, I'm told I need to move the CLI up a little bit here. Does that work? Great, okay. Okay, so we've got an S3 bucket created now, and let's go ahead and do a few more interesting things with that bucket. So first I can say bucket.onPut, and so I'm going to say on input, new input. And this, you can see here, because I'm using TypeScript, I get a little bit of help inside my editor to tell me all the sort of things I can do here. And I'm going to say, when I get a new input file, I want to run a little piece of code. And why don't I just print that out, and I'll say new input file. I'll print out the bag of data that I got given there. Okay. And so what this will do is it'll say whenever a new file is placed into the bucket, run this piece of code here. And that's just a handy way to react to that event. And in fact, what I want to do is just only fire that if the item gets put into the input bucket. I'm going to create this thing where I have two buckets, where I have two folders, the input and output, and when things get placed in the input, I process them and move them over into the output folder. Oops. Process them and move them over into the output folders. Okay, so here we go. I've got some code I'm going to run only when items are placed into the input bucket. So let me go ahead and come over here, and I'll just do another Pulumi update. Now, the first thing to notice here, we're going to see that preview again, but you'll notice that it's not going to go and try to create that S3 bucket again. We have the existing application already deployed, which has that S3 bucket, and all we're going to do is see what is the delta we need to provision in AWS to bring these new capabilities that I just authored into my application. And so you'll see that that basically is two things. One, it's this new input function, so this cloud function here, which involves building up a few different resources. It involves building up that AWS Lambda. It involves provisioning some roles and policies. And then also this bucket notification, which is the thing that hooks up the bucket to that function to execute. And so the key thing here is the app that we're building, we're describing in terms of sort of what we want to do, but the implementation of it is actually being deployed as managed AWS resources. So we're getting the benefits of all of the great work that AWS has done with S3, with Lambda, with all of these different managed services. But we're able to use those and compose those in a really simple way in our code. So okay, let me go ahead and perform this update. This is going to take just a little bit to create those resources. So you'll see it's creating the roles and role policy attachments, and then it's creating the function. Currently, the function is going to take about 30 seconds or so to create. That's something that we're hard at work improving, and actually in our development branches right now, it's just taking a few seconds. So we're really excited to have that to make this inner loop even more productive. But for now, we'll just wait a few seconds on this until it completes. So while that's going, let me go ahead and just sort of build out the next part of this. And for the next part, what I'm going to do is actually have handle files getting placed into the output folder as well. So I'll say new output, and I'll only fire this on the output folder. And then just to make something work real quick here, let's go ahead and when a file gets placed on the input into the input path, we'll just copy it directly over into the output path. And so I can just write some code in here. So I can say let file name equals, and I'll say args.key. So this is the file that was placed. And since that is going to be input / something, I'll just say split on / and get the second part of it. We could, of course, write this a little bit more robustly if we had more time, but I'll just go ahead and do it the simple way for now. And then I'm going to get the contents of that file. So I'll say await bucket.get. And so this is a way I can go and actually get the contents of this bucket at a given path. And so I'll just say args.key. And then I want to go ahead and put that into the new location. So I'm going to say bucket.put. The new location is going to be output / file name. And I'm going to place those contents in there. Okay, so this will just copy over those files into the output folder. And this should fire off this other Lambda. So there we go. I've written some code to do that. So let me come back here and just look at kind of what we did. It ended up taking 44 seconds, so definitely something that we're going to make even better. But it's pretty amazing we're able to deploy all these different resources into the cloud, really quite quickly here. So I've now got this that first piece of code running. And let me just start by doing a couple things. So first off, let me copy a new file over into that folder. So I'm going to copy over this file into, and let me get the, first off, let me do a Pulumi stack output to see what the name of the folder is, the bucket. And then I'll just copy a file into that folder. Okay, oops, got the command wrong. Sudo AWS S3 CP, copy that file into the folder, and that should trigger that original event handler we had. And so I'll say Pulumi logs now to kind of see if we can look at those logs that we got from the console.log command. And I'll just do -F to wait until we get some logs here. So we see that just a little bit after we copied it in, we got the logs provided from that. And so this said on new input, which is that function we wrote, I got the bag of arguments. So the key was input Pulumi YAML, was 41 bytes, and we got the event time that it happened. And so this is kind of neat. We can both write and deploy the application, but then we can get logs for all the behavior of the application. So all of that compute that we write inside these callbacks and things, I can access directly from my logs and sort of interact with that here. Now these logs are actually themselves coming directly through CloudWatch, because that's what we're targeting AWS. All the logging for Lambda and all of our APIs is going into CloudWatch. And so if I just open up the app again here, you'll notice if I come over here, I can actually come and look at my my function. So let me click on this. And this is going directly to my Lambda function in AWS. And you see it did get fired once in AWS. And if I jump to logs in CloudWatch, we'll see those same logs that we pulled, this new input file, same logs that we pulled from Pulumi. So all of this is really just using the raw primitives that are available inside AWS, and we're taking advantage of that. And you can go and use it at the level. You can go spelunk around in the AWS console if you want to, but we're making it really easy to interact with that through the CLI here. Okay, so let me do another Pulumi update to deploy those changes that I just made. All right, and this time we see a couple of things. So one, that new output function that I wrote is going to get deployed. So that one's getting created here. You see the bucket notification is getting updated because we now have two different notifications that we're wiring up to this bucket. One from the input folder and one from the output folder. And then we're actually going to update the code because we changed the code of that first function to actually copy the file over. And so again, you see that Pulumi is just identifying the specific changes I need to make to deploy this code into my application. And I say yes, and it'll go ahead and sort of do that work. Okay, so again, that's going to take around a minute to deploy. One of the things while that's going, I kind of just want to show a little bit more of is kind of what these projects look like that we're building on top of. So we're using this Pulumi Cloud library. And Pulumi Cloud is just a package of Pulumi programs that is available for anyone to build on top of. And so this is the kind of library that you could build yourself. Many of the folks who've been using Pulumi so far have built their own libraries that do similar things, but in the domains that they're working in. The Pulumi Cloud library is really targeting being a high-level framework for doing cloud programming, and being one that uses general high-level concepts that can be applied across multiple different cloud providers. And so in the future, we'll have support for Pulumi Cloud targeting Azure and targeting other platforms as well. And so if I come in here, I can kind of look at how this bucket class that I'm using works. And for instance, if I come to its constructor in the library, you'll see that it's just doing the kind of things that I could do in Pulumi, but it's taking care of a bunch of the heavy lifting for me. So under the hood, it's creating an AWS S3 bucket, and it's providing some good defaults here. It's when I hook up an event handler, so when I do an onPut, it's going to call this add handler method, which is going to create a function and a Lambda permission and a whole bunch of the underlying pieces that I might need to stitch this together. And so all of those things that you would have to do manually, either using some YAML files if you're using CloudFormation or Terraform or these sorts of things, or describe using sort of some bespoke config language if you're using a bespoke serverless tool. All those things you can just express as a library here and reuse them in your application code. And so the benefit of all this is, of course, I get to still use the raw AWS things, but I get to program them in a way that feels a lot more natural here. Okay, so that completed, and this application is deployed. And so let me go ahead and copy that file in again, and this time that should cause both of my lambdas to execute. And so I'll copy that in, and I'll run that Pulumi logs command again, and we should see what happens here. So that's from before. Let's see if we get some new events now that we copied that file over. Okay, so this time at 11:28, which is right about now, we got the new input, and then what is it? Just a couple seconds later, we got that second lambda filed when the new output object was placed into output/Pulumi YAML. So there's a couple of interesting things here. One is, we've with a very small amount of code stitched together kind of multiple lambdas firing off of an S3 bucket, sending data into and out of that S3 bucket. And we've been able to express all that in a very kind of what feels like to me as a kind of application developer, a very natural way. The second is with Pulumi logs here, because Pulumi understands the whole program, we're able to get kind of that aggregated logs across the different sources of compute. And so even though we have deployed two different Lambda functions to AWS, we can get a unified log stream for them from both this new input function and this new output function here. And so that's kind of a nice way to be able to think about your application as a whole instead of thinking about each of your lambdas as being a little island you've got to manage kind of separately. Okay, so that's kind of a little working sort of serverless example. There's a couple of directions that we might want to go from here, and I'll try out a couple of those, and we'll see how much time we have to kind of look at a few of them. The first one that I think is really exciting is bringing kind of containers into this as well. Containers give us a way to sort of run arbitrary compute that we may have in our application. We can, as long as we can create a Docker file that wraps that compute up, we can run it inside the cloud providers. Now the challenge with kind of running Dockerized compute is, while it's really easy to, if you're using Docker on your local machine or Docker Compose or something, it's really easy to get that up and running locally on your machine. What tends to be a lot harder is sort of getting that into the cloud provider and running it on top of a managed container service. And so one of the nice things about Pulumi is that we can express it in that really natural way, like you would if you were just deploying it using Docker Compose locally. But we can turn that into something which actually manages and deploys all the necessary infrastructure in the cloud provider to give you that sort of production-ready container deployment. And so let me do a quick thing and say, let's say I'm going to write process file, and this one's going to be a new cloud.task. And cloud.task is just a piece of containerized compute that I want to be able to run on demand. And so I can come in here and I can look at it, and again, kind of using TypeScript and Visual Studio Code, we can get some help to sort of learn how to use this API. And so we can see that there's a bunch of options for how I can configure this task. And I could configure it by passing it an image. So if I've got a pre-baked image that's already available in the Docker Hub or in the private registry, I can reference that image here, and that would work just fine. But oftentimes what I want to do is actually build my own custom Docker image that's part of my application and deploy that along with my application. So what I'm going to do here is I'm going to put that in a local folder. And so I'm going to say I want to build the contents of this local ./process file folder, and that's going to build a container that I want to push and be able to run remotely. The other thing I'm going to do is just sort of say how much memory I want. So I'm going to give this thing 1 GB to run with. And then I'm going to call that done for now. So let me come over here. I said that this file existed in process file, but I haven't yet created that. So let me create a folder for this. I'm going to create a little Docker file here. And I'll just say from Ubuntu. And I get some help there. And let me actually, I'm just going to borrow a little bit from here. Let me borrow some commands right here that will just run apt-get update, install Python, and then pip install the AWS CLI. Once I've done that, then I can sort of write some arbitrary code in here, and this could be implemented in any language. I could have done this in Go, or I could have done this in Java, or I could have done this whatever. I'm going to just use the AWS CLI directly to do this. So I'm going to say AWS S3 CP, and I'm going to say bucket / input, and I'm going to copy that to bucket / output. Okay, so this is a really simple Dockerized application. It doesn't actually have a ton in it, except it's got the whole Ubuntu image that I can use. It's got the AWS CLI, and then it's got a little bit of custom logic for how to invoke the AWS CLI. This is just going to do that exact same thing that I had been doing inside the Lambda previously, where I just copy the files between the two buckets. But this time I'm going to show kind of moving that compute into a container and running that on demand. So let me come over here, and I'm still going to use the file name, but instead of me copying it like this, what I'm going to say is I'm going to grab that process file that I had above, and it has a few different APIs on it. The most important one is run, and run is an API which lets me run the task. So I can kick off an instance of the task, and that will spin up a container, run it to completion. When it's done, it'll tear it down. And so let me say run, and we can see I have a few different options for what I can pass to this. Environment and host. The environment is the one I'll need because I referenced a couple of environment variables there. So I want to say bucket, and for bucket I'm going to say, what do I have, bucket name above? So I want to use the bucket name, and I'll call .get. The input, I want to be the input file name, and so in this case that's args.keep. And the output, I want to be the name that I use for the output, which is going to be output / file name. Maybe even for consistency, I'll just kind of rename this to okay. Okay, so that's going to go ahead and run that. Now this actually returns a promise because it will return once it's launched the task. And so we'll go ahead and await that. And then once that returns, I'll just say started task. Okay. So now we'll print out, once we've kicked off that task, we'll print out started task. And then once that task completes, it should put the S3 file in and kick off this other Lambda over here. Okay, so let me go ahead and come back over here and just do another Pulumi update. Okay. So we got an error. Always good to get errors. Lets us see the real experience for using this. When you're really working with any piece of technology, you tend to run into things you've done wrong. So in this case, I forgot to add some configuration. So the error message here says that I cannot create a task. I'm missing cluster configuration. And so there's 3 options for what I could provide. And this is actually sort of an interesting thing. So today I'm going to actually use Fargate, and so that's the 3rd option here, is I can provide the setting Cloud AWS use Fargate, and I'll set that to true, and that will run our containerized compute using Fargate. There's actually 2 other interesting options which I won't use today, but are actually really interesting to think about. One is that I can use Cloud AWS Ecs Auto Cluster. And what this will actually do is spin up a whole cluster for me in the EC2 container service. So it'll spin up some EC2 VMs, it'll register those in a ECS cluster, and it will then run the containerized compute on top of that. The other is ECS cluster ARN, which is if I already have my own cluster that I've deployed, my infrastructure team has already deployed an ECS cluster somewhere, and I just want to run my compute on that existing thing instead of running it either in Fargate or on a new cluster, I can just provide the ARN for that cluster, and all of the compute will get scheduled there. And this is actually one of the things I think is really interesting with using kind of these libraries like Pulumi Cloud, is we can write this code that just says, hey, I want to run this task. And that's sort of what logically I think about as an application developer is, hey, I've got this task, I want to run it. And then we can provide configuration that specifies kind of how to connect that into my AWS environment in the way I want. So just by switching a config variable, I can switch from using Fargate to using my own custom ECS cluster. And so my code stays the same. The way I express what I want to do is the same, but the set of resources that will actually be managed and created in AWS is going to be different in those 2 cases. So with that background, let me say I'm going to set this variable. So I'm going to set cloud AWS use Fargate true. Now, I haven't spent much time talking about Fargate. It's worth just for folks who haven't used Fargate before, talking for a second about that and kind of why we're using it here and why we think it's sort of interesting from a Pulumi perspective. So Fargate is a way to, if you're using AWS and you want to run containers, it's a way to run those without having to manage any EC2 instances or any infrastructure yourself. You can just say, hey, I've got a task, I've got a container, I want it to run that in AWS. And so this is really great from kind of a Pulumi developer perspective, because it means that you kind of get to offload not just the complexity of what resources to create, which is something Pulumi is great at taking care of, but it means that operational burden of dealing with all of the underlying infrastructure for your application, you get AWS to take care of that for you. And this really lets you focus on your application code and your logic and really quickly deploy it into the cloud provider and have a nice managed service underneath that. So we'll go ahead and use that. Let me say Pulumi update again. This time we'll see kind of some more interesting things being created. So first off, you'll notice this update here, and once it completes the preview, you'll notice that it actually ran a Docker build. And so because we had pointed at this folder on disk where we had a Docker file, that folder contained the specification of our Docker image, and so we're actually going to run, as part of the Pulumi update, a Docker build locally on your machine. And then we've got to get that Docker image from your local machine up into AWS. And so to do that, the cloud task abstraction actually goes and creates a repository in AWS. And so AWS has a managed concept, a managed container repository. And so we're going to go ahead and use that. And then we'll push that code up into that repository from the local Docker build. And then we'll connect it up into the running task. So we'll create an ECS task definition. We'll create a log group to collect the logs from that. And we'll create a few pieces of infrastructure. So we have to specify the network we want to connect to. And so we'll use the default VPC. We're not going to create any new networking infrastructure here. And we're going to just create a little cluster and security group to specify what the networking parameters are going to be for that. So all of this is sort of the boilerplate. If you've ever tried to use Fargate yourself, even though the service makes it really easy once you've gotten everything stood up, actually getting all the various pieces connected together is a little bit of boilerplate that you have to do typically every time you kind of want to use Fargate in a new application. And so one of the things we can make really easy here is just by writing, these couple of lines of code here. These described to Pulumi and to the Pulumi Cloud framework that it wanted to create all of these different resources here and hook them up in the right way. And again, all that's really boilerplate that you kind of would have had to do yourself. So I'm going to go ahead and say yes and kick this off. You'll see that the Docker build happened. You'll see now we're getting the updates as this is actually pushing that into the repository in AWS. And so the Docker build completed, and then we're actually pushing those images up to AWS. And let me go take a look at kind of what some of that looks like in AWS. So let's come back over to our resources tab. We can see all the resources that are now part of our application. And so one of the things we have is sort of a cluster. So this ECS cluster here. And we can come over. Let's just look at the repositories. Let's just see what we've got here. So we have this this repository here. Maybe we haven't finished pushing, so we may not have anything in there. Oh yeah, I think we're still in the middle of pushing some images up. Let me go look at the task definition then. I think we've already deployed that. Let me see. Maybe we haven't yet deployed that either. Okay, we'll wait for this thing to complete before we go look at those in ECS. So right now, it looks like we're still pushing this up to the repository. I think this Ubuntu image is not super small, so it's going to take a second to get that up into AWS, I'd guess. Actually, you know what? One of the other things we can do here in the activity pane, we see this update that I'm running locally on my machine. We can actually watch the status of that also in the console here. And we can see that in a little bit more detail. So we can see, here we have the full details of what's happening. And you see we're pushing up these images, these layers of the Docker image. And it looks like, yeah, it looks like we're still waiting. Oh, there we go. We just finished and finished pushing it up to the repository, and now we're creating the task definition. So this thing should be making progress now here as well. Okay, yep, now we're creating the function. So all these other resources have been created now, and our code has been pushed up into that registry. So let's go look at that over here. Okay, so here we go. We've got that image. It was 192 megabytes in the end. And this is that image that we pushed from our local machine, is now up in AWS. And there we go. So we completed that. So it took a couple of minutes there to get all that up. But the net of that was we created a whole bunch of AWS resources, built and pushed a Docker image from our local machine, and updated some lambdas to connect into that. So let me go ahead and just copy that file again and see if we can see what this new workflow does here. So I copy that file, and I'll just say Pulumi logs-f to watch this kick off. And here we see 11:43, so that's right now. We created that new input file, and then we hit that started task. So we actually kicked off that task in AWS. And so I can see kind of what's going on here if I come into my, let me just come back here and find the cluster resource. So I'll go over to this ECS cluster that's running my compute. And you can see that it's right now provisioning this task. And so because I kicked this off, this is the first time we're running this task in AWS. And so it's going to take a second for it to warm up. In the future, these things can run really fast once I've warmed up an instance in Fargate with them. But for now, this is the first time. It's going to provision some compute for me. It's going to pull down that image, all the things that Fargate will typically do when you've got some new compute. Easy went from provisioning to pending. It's going to take another second here to run. But over here, we'll see, once it does run, we'll see kind of the output from that task. One of the things you'll also see, I can come over and look at this task definition here. And so this has the full task definition that I provided, and so you'll see this hooks up to that registry we provided, says that this wants to run on Fargate, all the different details that we kind of took care of building that up. Here's an example. So this will take a little bit. Oh, there we go. Okay, so it ran now. So this was the command actually running inside of the container inside Fargate. And if I refresh this, it should say, okay, so now the task is completed. If I look at stop tasks, there we go, this one completed. And so now this is done, and now you'll see that new output got fired as well. So the lambda function on the other side of that got fired with the results of my container. Okay, so I think I kind of have run out of time for today, so I'll kind of start wrapping up here. Next time we'll spend a lot more time looking at containers and building things on top of some of the container technology here. But I just want to kind of highlight a few things about what we built in this particular example and how some of this kind of generalizes. So first off, this application again combined kind of three sets of things. It combined serverless functions and lambdas. So these callbacks here that I can provide, or each little lambda that got deployed into AWS and run as a managed piece of compute. And it used those to handle events on various data stores. And so in this case, I was working with just a cloud.bucket, which is going to be sort of an S3 bucket that I can store blob data into. But I can hook these things up to a variety of different sources. So in this cloud package, we have, for example, timers, so I can run compute on a regular schedule. We have HTTP endpoint, which gives me the ability to run in response to a REST API call. We have tables, so we have the ability to provision a NoSQL data store and hook events off of that. So a variety of different kind of sources of events that we can hook up to. But then on top of just deploying these serverless functions to that, I can also take arbitrary compute that I've got. And so in this case, I just wrote a Docker file that packaged up some AWS scripts with Ubuntu, and I ran that inside my application. Across all of this, though, the thing that I think is really interesting is just that we were able to express it in this very kind of natural application-centric way, but the end result was a whole set of managed AWS resources that we're able to compose together as part of our application. And just to summarize again, what we were doing here today was really using this cloud library, which gives me some of these high-level abstractions, makes it really easy for me to combine together these lambdas, containers, and managed data services. But you can do whatever you want with Pulumi. So if you want to just use a bunch of raw AWS resources or raw Azure resources, that's something you can go and do directly. If you want to combine those with these resources or send contributions to cloud to enable it to do more things, you can do that. And so we're really excited to get more folks contributing and building packages as part of the ecosystem of these higher level packages on top of the raw cloud providers. All right, so with that, I will close down for today. Again, we're in private beta right now. Definitely excited for anyone who's interested in playing around with this stuff to join the private beta now and start getting started building Pulumi programs, building Pulumi components, and giving us your feedback on the experience. You can get started at pulumi.com, and we'll see you next week to go a little bit deeper on containers. Great, thanks everyone.